Welcome back to the another video. In this session, we are going to be discussing about the what do you mean by damped oscillation and the equation of damped oscillation. Actually, what do you mean by damped oscillation? The damped oscillation, whenever the body is set for the oscillation, if you take the body, it's a simple pendulum, it will be having a simple harmonic motion and it will be having a displacement of x on the both side. It might be positive side and it can be negative side, and sinusoidally it will be keep on moving on. Now if this oscillation is set for on a body, then the body can't be at a free motion or the free oscillation, where the body won't come to the rest position. So if the body want to come for the rest position, there are the two types of forces which will be acting on that one. One will be always a restoring force. The restoring force is nothing but the force which is within the body, which will be enhance itself to pull the body for the rest position. It is called the restoring force. And another force which will be a resistive force. So another type of the force which is acting on a body, it is called as resistive force. So the resistive force can be pressure, atmospheric pressure, and any opposition force by external, it can be called as a resistive force. On this combination of this both will impact the damping. Damping is nothing but a bringing back for a body which is set for the oscillation to the rest position or a equilibrium position at a certain interval of time, means finite interval of time, within a limit, some certain limit of time t. So this type of oscillation is called as damping oscillation. So the reason for the damping oscillation is a restoring force as well as a resistive force. Now we are going to be deriving an expression for the damping oscillation. Now I have told that the two kind of the forces which will be acting. First, it will be always resistive force. So the resistive force, if a body having a mass of m set for oscillation, so the body of mass m is set for oscillation, then the resistive force of a system is given by negative of small r dx by dt, where r is equal to damping constant and dx by dt is the velocity of the body which is oscillating actually. So these two impactfully, it will be giving the resistive force for the system, where negative sign, it is indicating that it is opposing the motion of the body to bring to the alt position or a rest position. So take it as equation number 1. Now the second opponent is always restoring force. This is the force which have been studied in also free oscillation. So it is similar, nothing but which is equal to negative of k into x. Take it as equation number 2, where k is force constant and x it is displacement of a body at an interval of time t. So this is the restoring force. These two forces combinedly acting on a body to oppose the motion for bring the damped oscillation. Now net force or resultant force acting can be given by resultant force. It is given by F is equal to negative of R dx by dt negative of k into x. Take it as equation number 3. So we all know that according to the Newton's second law of motion, where the force is given by mass into acceleration. In terms of derivative, I can write this as mass into d square x by dt square. Take it as equation number 4. If you apply this equation in terms of equation number 3, then the equation will be turned into m into d square x and dt square is equal to negative of r into dx by dt minus k into x. If you shift LHS and RHS into one side, mass is equal to mass into d square x and dt square x plus r into dx by dt minus it become plus k into x is equal to 0. You write it as equation number 5. Now, in a derivative, in a first order, we have some constant. I need to remove this constant. Now, by dividing full equation by m, I will get d square x dt square plus r by m dx by dt plus k by m x is equal to 0. By observing this equation, I can say that r by m is equal to constant, which is called 2b, and k by m is equal to omega square, where omega is given by angular frequency, which has been derived in a previous equation. So apply this here, d square x and dt square plus 2b dx by dt plus omega square into x is equal to 0. Write it as equation number 6. So this equation is called as equation or a differential equation of a damped oscillation, and this equation should be solved by taking the solution for these equations in a derivative